everybody, this is Miss Phoebus, and this is Lesson 31, Factoring Quadratics with a leading coefficient other than 1. Are you ready, guys? We're going to slide and divide. All right, so we are looking at factors. We're looking at factoring a trinomial into two binomials when a is not equal to 1. If a is equal to 1, we do what we did yesterday. Today, what happens when a is not 1? What is that leading coefficient going to do? We are factoring quadratics. So we are on page 131 in our notes. So if you want to turn there so you can copy down the notes. Remember, your test is either Thursday or Friday, and you can use your notes. So if you are not using your notes and you're not taking notes, shame on you. Take notes. Use notes. All right. So you are going to use this factoring method when the degree is 2. You are dealing with a quadratic. There are 3 terms. We are dealing with a trinomial, but the leading coefficient is not 1. It could be anything. It could be 2. It could be a half. It could be lots of different things. And so what we're going to do is we are going to have this a value in the very, very front. That is our leading coefficient. And what we're going to do is we are going to slide and divide. And we'll get into the process in just a little bit. But you are going to slide this a all the way to the end and multiply it times c. So you are going to find 2 numbers that multiply, give you whatever a times c is. And then add to give you b. Now with that slide, that makes factoring a little bit easy, but then we have to undo that multiply, so that's where the and divide comes from. And it's, again, a process. We're learning a process. So here are your steps to factoring success. Write these down. Step 1, factor out a greatest common factor if possible. The leading coefficient, you want it to always try to be a positive number. So if the leading coefficient is negative, you want to factor out a negative at the very least for the greatest common factor. So you are going to check for a greatest common factor and factor it out. Then you're going to slide a to the end and multiply it with c. You're going to factor like normal. And then you're going to divide the constants by a, reduce the fractions if there are any, and then I'll show you what to do with those. But we basically are going to slide, factor, divide, and when we divide, we always simplify our fractions. Always, always, always simplify our fractions. Okay, there is a step 5 and 6. Step 5, we're going to move our denominators, and that's going to turn them into coefficients. And then we're going to multiply to check. Again, it's a required step. You are required to check. Checking is very important, especially in this factoring process. There are more steps, and so we're going to have to play around with this. So this method is called slide and divide. There are other methods out there. I've been teaching this for a long time. So I have tried the other ones, and actually I avoided slide and divide for a long time because I pretty much didn't understand it. But once I took the time, I watched a couple videos on my own, I was like, you know what? There's a lot less writing. We're able to get to the answer faster. So I actually have started embracing slide and divide within the past 5 or 6 years, and it is my go-to method. If you do not like this method, and you would prefer to have another one, you need to contact me and we'll see what we can do for you. But slide and divide is usually the way I go, and because of that, some of the other teachers are using it a little bit more than they used to in the past. All right, so here we go. Number 1, we've got 3t squared plus 4t minus 15. So we're first going to check to see, is there a greatest common factor? So that is the first step. Is there a greatest common factor? Well, I can divide everything by 1, but I don't want to do that. Dividing by 1 isn't going to change anything. So there is no greatest common factor here. Now, I'm writing this out right now, but these would be questions that I would ask myself. And if there is a greatest common factor, then I want to remove it. In removing a greatest common factor, you are doing something called factoring completely, or doing a complete factorization. Complete factorization, it's really long to write, is your greatest common factor plus factoring normally. Okay, so you want to completely factor, you better have a greatest common factor factored out of it, if there is one. So in number one, there is not a greatest common factor. So then what we're going to do is we're going to get into slide and divide. So we are going to identify, and I usually like to circle my leading coefficient. That's not 1. In this case, it's 3. And we're going to send it to the end. We're going to slide it to the end, and when it gets there, it's going to get multiplied times that value that's already there. So what I'm doing is I'm moving the 3, I'm sliding it down. I'm going to be left with t squared plus 4t and then minus 45. So all I did was I picked up the 3, I said 3, we don't want you in the front, you're no longer the leading coefficient, chucked him in the back, and when he got chucked, he got multiplied by the number that was at the end. Now we're ready to factor, so this should bring back what we did yesterday. So I've got blank times blank equals negative 45, blank plus blank equals 4, and I want to factor like normal. So I'm going to think about what multiplies to give me negative 45, adds to give me 4. I'm thinking negative 9 and positive 5. Oh, not negative 9, positive 9, negative 5. That's going to get me a 4. So positive 9, negative 5, and so I'm ready for my parentheses. So I'm going to come all the way up here, parenthesis time, and I'm going to have t plus 9 and t minus 5. All right, I want to take a moment to kind of talk some things out through to you. Because at this point, people are usually like, woo, I'm done. I'm going to multiply. I'm going to get t times t. And I'm going to say, are you getting, when you do t times t, the original 3t squared? If you are not, do not continue on. And usually when we do this on pencil paper and I'm writing things, the most common thing that I will write from here until the end of the semester is, you did slide, but you did not divide. So we have to undo that multiplication of the 3. We multiplied over here by 3. How do you undo multiply by 3? We divide by 3. And so what we're going to do is we're going to divide each of the constants by 3 to undo that multiplication. We're going to simplify. So look at that. You see that 9 divided by 3. 9 divided by 3 is 3. So that ends up being t plus 3. And then this 5 divided by 3, that's not going to simplify at all. But if you notice, I don't have any fractions either in this quadratic trinomial. So what I'm going to do is I'm going to take this 3 and I'm going to bump it up and I'm going to make it a coefficient inside or for that t. And really what I'm doing is I'm multiplying both parts by 3, but we usually don't talk about it like that. But that's usually what I'm doing is I'm just bumping that 3 up and making it coefficient. And you're going to see why in a second. So all I've got is that 3t minus 5. Remember, this is a process. You're learning a process. But this is my answer, and I'm going to check it just so that you can see what we've got going on. T times 3t, look here, we've got 3t squared. If we had not moved that 3 right here from the denominator up in front, we wouldn't have gotten 3t squared. So that move allows us to get the 3 in that 3t squared, and then we're going to have minus 5t plus 9t, and then minus 15, and then we've got 3t squared plus 4t minus 15, which is what we originally started with. Okay, so it's a process. It's got a lot of steps, and the more that you want to get through and try to understand the process, you're just going to have to get used to the steps and when do you stop and all that kind of stuff. Okay, so there's our answer, t plus 3 and then 3t minus 5. Now, because we have a leading coefficient that's not 1, we should expect to have something, at least one coefficient. In this case, we have a 3 in front of our linear term. We should expect one coefficient there. All right, let's just do more examples. That's how we're going to get better and better at this. So we're going to look for a greatest common factor. Do we have a greatest common factor here? We do. Our greatest common factor is 6. I can divide 18, negative 12, and negative 6 by 6. And so I want to go ahead and pull out that greatest common factor. So that means I've got 3k squared minus 2k minus 1. This goes into that complete factorization. Is it factored completely? Like this one is factored completely. There wasn't a greatest common factor, but it is completely factored. If I just do the slide and the divide with the 18 and send it to the end to be multiplied times the negative 6, I won't have factored out that greatest common factor, and actually I'm in danger of reducing down and losing that greatest common factor in the reduction of my fraction. So I want to watch out for that. So greatest common factor is important. You want to pull it out. Now you don't want to lose it. That 6 is already kind of pulled out, but we're going to ignore it for just a moment. And what we're going to do is we're going to work with the slide and divide just inside the parentheses. So we're going to slide that 3 down and multiply it times that negative 1 that's already there. So when I do that, and again, I'm just going to focus on what's inside the parentheses. I'm going to have k squared minus 2k minus 3. And we need to factor this. So we're going to find two numbers that multiply to give you negative 3. Those same two numbers have to add to give you negative 2. And we're looking at negative 3 times 1. Negative 3 times 1 is negative 3. Negative 3 plus 1 is negative 2. So we will be able to factor this into, I'm going to go ahead and pull my 6. Remember your 6 from the beginning, our greatest common factor? I'm going to pull that out again. I don't want to lose it. It's part of my answer. And then this is going to be k minus 3, k plus 1. And then remember, if I do slide, I have to divide. So what did I slide to the end? That's why I circle this in the beginning. I circle that 3 because I know I'm going to come back and I'm going to divide by 3. Okay, we're really close to being done. So still got that 6 on the front, k, and then minus 3 divided by 3. 3 divided by 3 is 1. Can we simplify this right here, this 1/3? 1/3 is completely simplified, so I'm not going to be able to simplify it, but I can't leave it in that fraction either. So do you remember what I need you to do with that denominator? Just like we did up here where we moved that 3 up in front. In this case, we also have another 3, so we're going to move that 3. We're going to move it right up in front right there. So that's going to make it look like 3k plus 1. All right, we're going to multiply, and when we multiply, you can do this one of two different ways. If you want to distribute this 6, you can just into one parenthesis. So that makes it look like 6k minus 6. I'm going to run out of room, so I may jump up a little bit higher up here. And then 6k times 3k is 18k squared. All right, now we're going to do 6k times 1 and get plus 6k. Then negative 6 times 3k is negative 18k. And then negative 6 times 1 is negative 6. Squeeze that in there. It's hard to see, I'm sorry. And then we end up with 18k squared minus 12k minus 6. Is that what we started with? Oh, it is. So that means that what we have here is we have our, let me try cleaning up. We have our answer, and it's completely factored. Now, the reason why I wanted to show you this was, yeah, we were checking. But here, this looks like it is factored. But it is not a complete factorization because I have a greatest common factor. Do you see in that first parenthesis? I could divide both of those parts by 6. So I do not have a complete factorization here. So this is a complete factorization, whereas the one below it is not. And it's just one of those things. Is it completely factored? or is it not completely factored? So that's what's going on in that terminology. You're going to run across that in your homework. It's going to ask you if you have a complete factorization. You're going to be looking for, well, was there a greatest common factor that could be factored out, and that kind of thing. So the complete factorization has all of it broken down into all its components. We have the greatest common factor already pulled out, and then we have two sets of parentheses. All right, so we're looking for number 3, a greatest common factor. I do not have a greatest common factor. However, my leading coefficient should always be a positive. Okay, that is something that you want to have, because when we do slide and divide and we slide a negative down, it gets a little messy. So what we want to do is, if we remove that negative out of the equation, or the expression in this case, then we don't have to worry about signs and all of that kind of stuff. I've had lots of trouble doing slide and divide with a negative leading coefficient. So I found that it's more helpful to go ahead and just factor it out. So let's do that. We're going to do a leading coefficient. We're going to do we're going to do a greatest common factor of -1. So we're going to factor out a -1. So everybody gets divided by -1, making that 5a squared minus 8a minus 4. Now my leading coefficient is a 5. It's positive. Now we're going to do slide and divide. So we're going to take the 5 and we're going to slide it to the end. Just check it to the end and multiply it times the -4 that's down there. For some reason, it doesn't matter if there's a -4 at the end. It'll all work out. But if it's the leading coefficient is negative, it causes trouble. So we're dealing with a squared minus 8a minus 20. And we're going to factor that just like we did yesterday. So we want to do blank times blank equals -20. Blank plus blank equals -8. So we want to know what multiplies to give us -20, adds to give us -8. And we're looking at -10 and +2. We're just playing around with those numbers, that's going to work. All right, so then that means we're going to factor. Now, I'm going to go ahead and write my -1 just so I don't lose it. And then we're going to have a minus 10, a plus 2. And then we've done our factoring, so it's slide, and then it's factor, now it's divide. So did slide, now we got to do divide. What are we dividing by? You see that 5 right there? That 5 we slid down, that's what we're dividing by. Divide by 5. So I'm looking at, bring this up here, a -1. You could just have a negative in front as well. A minus 10 divided by 5 is 2. And then 2/5. That doesn't reduce. So remember, if I have a denominator, where does it go? It goes up in front and becomes a coefficient. So it's going to go up in front of a. So it's going to become 5a plus 2. And then we're going to multiply. So I'm going to go ahead and distribute this negative inside and get -a plus 2. And then I'm going to multiply. So -5a squared minus 2a plus 10a plus 4. That ends up being -5a squared plus 8a plus 4. Is that what I originally started with? It is. And that means that this is my answer. Now, technically speaking, this is also an answer, but we're just kind of going based off of the leading coefficient should always be positive. If you can do slide and divide and not have trouble with negatives, I've had trouble every single time I've done it. And so I think that it's a little bit easier if you pull out a greatest common factor that's a negative. Just my personal opinion. From one expert to new mathematician doing this, I feel that that is something that makes it a little bit easier. All right, we're going to look at number 14. Do they have... All right, we're going to look at number 4. 14r squared plus 53r plus 14. So is there a greatest common factor? 53 is not divisible by 2 or 7 or 14. So guess what? There's no greatest common factor. Do not force one. That's the thing. We want to play with nice integers. We are not creating fractions. That adds to the madness of all this. We want to just play with nice numbers. Okay? So there is no greatest common factor. So what's our next step? We're going to slide and divide. What are we going to slide? We are going to slide the leading coefficient to the end and multiply it times the 14 that's already there. So we're going to end up with r squared plus 53r plus 196. You may not know the factors of 196 as we get ready to factor this, but we already know that 196 is 14 times 14. That is something. And I usually say, well, 14 is 2 times 7, and another 14 is 2 times 7. So we're going to play around with these numbers, and we may be able to multiply some things together so that we're working with numbers that add to give us 53. So we want to multiply to get 196. We want to add to get us 53. Well, 53, look here, 7 times 7 is 49. 49 and 2 times 2 is 4. 49 and 4. That gets me 53. Woohoo! That's what I like to do. Okay, so then now we're ready to factor. So we've got r plus 49, r plus 4. But we don't stop there because we did slide, but we didn't divide. So we're going to divide, and what are we dividing by? 14. Now, we're going to create two fractions, and both of these fractions are reducible. 49 and 14 are both divisible by 7, and 4 and 14 are both divisible by 2. So I want to reduce those fractions. That's one of the reasons since the very, very beginning, I've been like, you've got to simplify your fractions. You've got to simplify your fractions. I knew this was coming up. I wanted this to be in your head. You had this maybe compulsion to simplify your fractions. Some of you need to get that compulsion. But what we're going to do is we are going to rewrite this where we have our fractions simplified. So this is r plus, all right, 49 over 14. We know that they're both divisible by 7. 49 divided by 7 is 7. 14 divided by 7 is 2. Okay, and then we're going to come over here. We're going to have r plus, and then now 4 divided by 14. We know that they're both even. They're divisible by 2. 4 divided by 2 is 2. 14 divided by 2 is 7. All right, we can't leave it like this because if we check, r times r is not 14r squared. So we've got to move those denominators. So we're going to take this denominator and bump it up in front. So that's going to make it look like 2r plus 7. And we're going to take this denominator and bump it up in front like a coefficient. And that's going to be 7r plus 2. And so this is going to be our answer that we're checking. Let's check it. 2r times 7r is 14r squared. 2r times 2 is 4r. 7 times 7 is 49r. 7 times 2 is 14. Let's combine our like terms. Plus 53r plus 14. Does it match? Ooh, look, it does. All right, so here's our answer. So it works. And we will get to a point where we're not having to write so much, but there's a lot of stuff going on. I just want to make sure you understand, especially you can't see me in person if you're watching on the video. I want to make sure you understand where these numbers are coming from. That I'm not just making them magically appear. We are going through a process, and we do see these things changing. But as you get better and better and you have more and more practice, you can write less and less. Let's do another one. All right, so 5. Is there a greatest common factor? There's not. You want one, right? 25 and 20. Even 20 and 4, they have a greatest common factor. But all 3 terms, nope. No greatest common factor. So we're ready for slide and divide. We're going to send that 25 to the end. I always do this part. I always write this. So I'm looking at y squared plus 20y plus 100. I want to find 2 numbers that multiply to give me 100 and add to give me 20. I love these numbers. They're 10 and 10. 10 and 10. Now, let's get them in parentheses. So that's y plus 10 and y plus 10. We do see that they are going to be the same, so we might be able to write this as something squared, but we're not done yet, because remember we did slide, we've done factor, now it's divide time, and what are we going to divide by? Yep, we're going to divide by this 25 that I have right here, and we're going to have to simplify those fractions, but the nice thing is that they're the same fraction, right? 10 over 25, I only have to simplify one fraction. They're both divisible by 5, so that means that I've got y plus 2/5 and y plus 2/5. Can't leave them as fractions. Do you remember what to do next? Take those denominators, bump them up in front, make them coefficients. Now I'm leaving these as 2 separate pieces because I do want to multiply to check. 5y plus 2 and 5y plus 2. But I'll go ahead and say if these check, then we would be able to write our final answer as 5y plus 2 squared. So let's double check that, make sure I didn't make any mistakes. So 5y times 5y is 25y squared. 5y times 2 is 10y. 2 times 5y is 10y. 2 times 2 is 4. We've got 25y squared plus 20y plus 4. That's what I originally started with. So yes, this is the answer, but I would argue that this is a better answer. It's written more simply and more compactly. All right, is there a greatest common factor? I don't see one. I see 6 and 6, but 7 is not going to be helpful. So we're going to slide and divide. We're going to slide this 6 to the end and multiply times the 6 that's already there. So we've got m squared minus 7m plus 36. I want to find 2 numbers that multiply to give me 36 and add to give me -7. So 36 is 1 and 36. Doesn't work. 2 and 18. Nope. 3 and 12. Nope. 4 and 9. Nope. Not 5. 6 and 6. So we're going to go ahead and say, hey, we tried, but it's unfactorable. But I tried. Did you see? You see all the factors that I wrote? I tried real hard. The area of a rectangle is 2x squared minus 5x minus 12. We're going to factor. So this is an area problem, so it's just more slide and divide stuff. So we've got 2x squared minus 5x minus 12. Question is there a greatest common factor? There is not. So we're going to do slide and divide. We're going to slide this 2, slide it to the end, multiply by the 2 that's already, multiply by the 12 that's already there. And this is going to be x squared minus 5x minus 24. We want to find 2 numbers that multiply to give us -24 and add to give us -5. And the answer is -8 and +3. All right, so that means we've got x minus 8, x plus 3. So that is the factoring process. If I stopped right here and did x times x, I would not get 2x squared, so I'm not done. I did slide, but I've got to divide. I'm dividing by the 2 that was originally in front. All right, so I get x minus 4. Now this 3/2 is already simplified, so I could go ahead and bump that 2 up to the front and kind of save a little bit of space and have 2x plus 3, and then multiply to check. So x times 2x, ooh, look, it's 2x squared. We're on a good roll there. Plus 3x minus 8x minus 12. And then that's 2x squared minus 5x minus 12. All right, I think we got 2 more to go. So the area of a rectangle is 4x squared plus 5x minus 6. So we're going to factor this to reveal its dimensions. So we are going to look for greatest common factor. I don't see one. So then, since this is already written, I can go ahead and do that slide. And the next thing that I'm going to write is going to be just what I get after I do that slide component of it. And then I want to find two numbers that multiply, give me negative 24, and add to give me 5. So we're looking at negative 8 and 3. And then we're going to have x minus 8, x plus 3. I can't stop there because x times x is not 4x squared. So I'm going to come back. I think these are the same numbers as the last problem, but we're not going to divide by 2. We're going to divide by 4. All right, so x minus 8 divided by 4 is 2. And then this 3/4 is already simplified. So what we're going to do is we're going to come up here. We're going to bump that up to the front and make this a 4x plus 3. And then we're going to multiply check. So x times 4x is 4x squared, looking good. X times 3 is 3x minus 8x minus 6. 4x squared minus 5x minus 6. That's what we started with. So here is our answer. All right, I think we got one more. If you feel adventurous, you can try this yourself. It's 6x squared minus 19x minus 7. See if you can factor. All right, we're going to go ahead and do our slide. So I've got x squared minus 19x minus 42. We're going to find two numbers that multiply, give me negative 42, and add to give me negative 19. Now I'm going to just focus on the 42. So that's 6 and 7, 14 and 3, 21 and 2. I think that's going to be at the 21 and 2. So negative 21 and positive 2. All right, so we've got x minus 21, x plus 2. All right, what did we slide? Looks like 6, so I'm going to come back and divide. All right, 21 and 6 are both divisible by 3, so that's x minus 7 over 2. And then 2 and 6 are both divisible by 2, plus x plus 1/3. And then we're going to move those denominators, bump them up, make them coefficients. So we got 2x minus 7, 3x plus 1. We've got 6x squared plus 2x minus 21x minus 7. That's 6x squared minus 19x minus 7, which is what we originally started with. All right, guys, slide and divide. Slide and divide. If you need help, remember tomorrow there's going to be an open Google Meet. You can always email me if you want to find a different method. We can do that too. But I'll see you guys in the next video. Bye.